Hi, Gaurav here. Um, so we are done with the air loop demand side. In this particular video 1.5, we'll do air loop supply side and we'll close the air loop. We'll do all the remaining objects for air loop. So as I told in a slide before, air loop supply side is a mix of outdoor air mixer box and an AHU. AHU consists cooling coil, heating coil, and a fan. Um, Before this, this all starts from this particular node, air inlet node, and to air outlet node. Um, for a convenience, it's a practice that we can make this all in one single branch, starting from this node to this node. So before that, first we have to make an outdoor air mixing box, outdoor air mixer. Uh, to make outdoor air mixer, we have to follow this particular order. First, we'll make an air loop HVAC outdoor air system equipment list, where in this equipment list we'll put an outdoor air mixer. Uh, to make an outdoor mixer, we need a node list and an outdoor air node list. Uh, Another part of this air loop HVAC outdoor system is air loop HVAC controller list. This this contains controllers and set point managers. And the third part of outdoor system air loop HVAC is availability manager, which consists availability manager night cycle. Okay, before starting, I'll give you an overview of what is an outdoor air mixer. Um, Outdoor mixer is a small box which has four different branches, four different ducts, pipes, whatever you call it. One is coming from the zone, and one is going to the cooling coil, and two pipes are connected to outside. This system regulates how much percentage of fresh air from outside is going inside the zone. There can be three situations. One, when a zone is being provided with 100% fresh air. So what it will do, there is a damper situated here. So the damper would be closed, and 100% from OA node, 100% from outside would be going inside the zone. Um, there can be a situation where 0% of outside is coming, so there would be damper here, and this would close off, and this would prevent any outside air coming. The air flow would be from air inlet to air outlet. There would be no air exchange between these two nodes. The middle situation can be different percentages can be controlled by moving the damper, which controls the volume. So this is the basic function of an outdoor air mixer. To make an outdoor air mixer, we'll start with air loop HVAC outdoor air system. Okay, this outdoor air loop HVAC outdoor system is situated in air distribution subheading. To make this, as I told you, we need three objects: controller list, outdoor air equipment list, and availability manager list. Um, First, we'll make an equipment list. Here um, we'll name it as OAS1. This is for outdoor system 1. So we'll first make an outdoor equipment list. Outdoor equipment list is situated here. Here we have to um, outdoor outdoor system equipment list is situated above outdoor system. Here we actually mark the outdoor mixer object. So we also make an object here. This would become AHU1 uh, OA equipment. There would be an outdoor air mixer. We'll define that. We'll make a new object. We'll name it as OAM1 for outdoor air mixer. OAM1. Okay, the mixed air node. We'll follow this diagram, plus we'll put one after every name for the three AHUs. So this would become mixed air node, this mixed air node, uh, this outdoor air stream node we'll name as OA node 1. Relief air stream node we'll name it as relief air node 1, and return air name would be air inlet node. This outdoor airstream node, this is actually an outdoor air node. Outdoor air means the temperature, the humidity, and the wind flow at this point is actually coming from the weather file. So we have to mark this node in a particular object name as outdoor air node list. This is really important, otherwise there will be an error. Here is the outdoor air node list. Um, First, we'll make a node list. What we'll do is we'll make a node list for every OA node of the three AHUs for the three outdoor air mixers. So we'll name it as AHU outdoor air node list. Um, and we'll mark here OA node 1. So we have made the outdoor air mixer. So here we can um, put outdoor air mixer, and this would be OAM 1. Yeah. We have made the list, so we can connect the list here. This would become OA1 equipment list. Now we have to make controller list. So we'll name it as AHU1 OA controllers. This would contain a controller of outdoor air, and that is here. What controller does is it regulates the amount of fresh air going inside the zone, as I told you before. So we have to make a controller for this. We'll name it as AHU1 OA controller. This would this is the relief air node. This would be air inlet node 1. This is sorry. This would be mixed air node. The work of an outdoor air mixer is to control the amount of fresh air coming from outside. So the actuator here would be the point from where outside air is coming, which is outdoor air node 1. We'll auto size these both, and we won't be using any economizer, and this would we'll set as 19, and maximum enthalpy we'll put it as 32,000. I'm seeing this from IO reference, and the minimum would be 0. Okay, here we have to mark minimum outdoor air schedule name. Uh, I have made a schedule minimum OA schedule. I'll just show you this. This actually contains when all this OA would be working. So it will be working till 9, from 8 to 9, and weekends it would be off, and in summer and winter design day it will be 1. Okay, so we have made a controller node outdoor air, and we'll connect it with the outdoor air system here. Okay, now to provide a set point to the controller, we'll make a set point manager mixed here, which will actually contain how much percentage of the fresh air is going into the zone. So we have to make a set point manager mixed here. We'll find this particular set point manager here. So we'll make a new object, and this would be called out OA mixed air temperature manager. So the reference set point would be the air outlet node. Air outlet node 1 is the reference would be actually that node which is the end of the supply side. Um, this would tell how much temperature of the air is actually needed at that point. So it will take values from there. Okay, here we'll mark the fan inlet and inlet node and fan outlet node. We haven't made these components till now, but we'll be making in the next video. Sorry, in this particular video only we'll be making this. So we can actually make setpoint manager mixture after making all these components, um, because we have made the chart which we are going to make, so we can input it here. This is fan inlet node. Fan inlet node and fan outlet node here is needed because um, sometimes because the motor efficiency is not exactly 1 in a fan, so it emits some amount of heat. So that heat is added into the air temperature, and so we require fan inlet and fan outlet here because energy plus um, calculates the difference of these both nodes, and that difference is provided the to the air coming before the fan, so that the resultant is okay. That's why we need fan inlet and outlet here. So this would be HC outlet node 1, and outlet would be air outlet node 1. The set point manager the set point is actually where the effect is going to come. The effect is going to be coming on mixed air node. Therefore, the set point node would be um, mixed air node 1. Now we are just left with availability manager list. That would contain the night cycle availability manager. This availability manager just tells when this OA would be working. We'll make an AHU1 availability manager. We'll put schedule as always on. Sorry, and the fan schedule will be fan availability schedule. This would be on cycle on any, and you can see the details of what it does is in IO reference, and we'll set cycling runtime as 1800. Okay, so now we have made this availability manager. We have to put it inside a list. We'll make a list here from here. We'll make a new object that this would we'll name it as list name. This would here we have to mark this night cycle, and so we are actually done with the outdoor mixer. That same thing I did for three outdoor systems. That was repetitive work, so I didn't showed you. After OA box, we'll be needing cooling coils. We have three cooling coils for AHUs, which we made previously during making branches. We need three heating coils for AHUs. We have made 10 heating coils for VAVs. So now we'll go to cooling heating water object, and we'll make three more heating coils. So we just copy it and make 3 HC1. This would be HC1 water inlet. No. Air outlet node, we'll take it from here. The air inlet for HC would be CC outlet node 1. This we have made previously. This would be CC outlet node. The outlet would be HC outlet node 1. This we had made while making set point manager. while making fan. We'll make two another heating coil similarly like this. This would be two and three. Before going to fan, we'll do a correction in nodes in cooling coil. We had defined the cooling coil in the starting, so we didn't knew about the air inlet and air outlet node. At that time, we had marked air inlet as CC1 air inlet node, but air inlet is actually mixed air node one for cooling coil, and outlet would be CC outlet node 1. So here we will do the correction. This would be mixed air node 1. Okay, after doing correction in cooling coil and making then making heating coil, we'll make three fans. Um, we'll make variable volume fan. Volume fan can be found here. We'll make three fan 1, fan 2, and fan 3. Availability would be fan available schedule. This will set as 500, and everything would be auto sized. These value you can see from the IO reference. I'll just type it fast. The air inlet node would be HC outlet node 1, and air outlet would be air outlet node 1. We had defined these previously. So now we'll make two more of this same. Okay, now the major step after making all these components is to make a branch. Uh, we have to make a branch which we'll input in air loop HVAC. This is same as we did in plant loop. We have to make the supply. We have to input the supply side node, demand side nodes. and connectors, mixers. We have to make that everything again. So we'll go to branch. We will go to branch and we'll make three new branches. Okay, the very first component would be air loop HVAC outdoor air system, the OA box which we just made. This would be air loop HVAC outdoor air system. This is OAS 1. The inlet is actually air inlet node 1, and the outlet for this is mixed air node 1. The second component would be a cooling coil. Cooling coil is named coil cooling water. Uh, this would be CC1. The inlet is mixed air node and CC outlet node 1. So you can see that the outlet for this is actually inlet for this. Uh, as we saw in branches, if two branches are connected, the inlet and outlet of the both of the both consecutive is not actually same. While in same branch, when we are connecting similar components, the outlet of one and the inlet of the next one has to be same. Otherwise, it will give an error. So mixed air node 1, and this would be CC node 1, CC outlet node 1. Then is coil heating water. This would be HC1, and this would be the same CC outlet node 1, CC outlet node 1, and this would be HC outlet node 1. After this, we have to define a, we have to input fan variable volume. This is fan 1, and input inlet would be HC outlet node 1, and outlet would be air outlet node 1. Now we'll make three of the same kind. Okay, after making these three different branches, these are main air loop branches. Now we can move to making air loop. We can move to making air loops. Air loop, you will find it here, air loop HVAC. So the very first would be air loop 1. We'll need a coil controller list name. This is a controller for the coils, for the both cooling coils and both for heating coils. Uh, Before that, we'll mark everything else: AHU availability list, and this we'll do auto design, auto size. Okay, we have to make a branch list also. I forgot that. So we'll make air loop branches one, and this would contain air loop main branch one. We'll make copy of this. These four nodes are actually marked before this. In this slide, I actually marked these four nodes. These were I did this for that air loop HVAC. So air inlet node and air outlet node would be for the supply side, and air demand outlet and air demand inlet would be for air loop demand side. So for the supply side inlet, it would be air inlet, and outlet would be air outlet. Demand side inlet would be we'll repeat this same for three air loops. After this, we'll make a control list and set point managers. We have made three air loops. The only remaining thing is controller list name. So controller list name we can make by first making controllers. Controller is actually an object used to control the flow of water going through the coil in order to meet the specified set point of the airflow from the coil. So we have to make three controllers for cooling coils and three for the heating coils. So controller water coil can be found above controller outdoor air. So we'll make CC1 controller. I'll just show you how to make both for uh, heating coil and cooling foil. Cooling foil for one, then I'll repeat the other. For cooling coil, we have to take action as reverse, and for heating it has to be normal. The reason you can see in IO reference, um, the actuator would be to control the flow. Um, in VAV also we saw that to actually control the temperature, we can just increase or decrease the volume of the air. Here also it's same, to control the temperature of the air we can increase or decrease the flow of cold or hot water. So the sensor would be actually, we'll be sensing the air temperature. This would be CC outlet node 1. uh, CC outlet node 1 is actually the node after the cooling coil. So it will sense what is the temperature here. If it's less, it will control the inlet of water in this cooling coil. So inlet would be CC1 water inlet. Okay, so after making controller for the six coils, we have to make a list of all these controllers. This will be done in air loop HVAC controller list. So here we'll write a coil controllers 1. This will be water coil, and this would become C1. This would be water coil, and this would become HC1. This will do two times more. After making a controller list, we'll connect this to air loop HVAC. Here it will show now coil controllers. Okay, now we have to connect these air loop HVAC. I'll again show you that zone diagram which I showed you in the beginning. So we'll be connecting ABC to AHU1, zone G to AHU2, and DEF and zone H to AHU3. So first we'll make a zone splitter. Zone splitter, we'll name it as AHU1 supply air splitter. This would be AHU1 supply air splitter. The inlet, the we have to see that inlet is actually air demand inlet node 1. This is the inlet of demand side of the air loop. So this would become air demand inlet node 1. Uh, the outlet nodes would be the three inlet nodes of the VAVs, that are VAV A1, VAV B1, VAV C1. So there would be VAV A1 box inlet, AV box inlet, and the same for three more. You have to see that in plant loop, while making splitters and mixers, we used to connect branches. Here we are connecting just the nodes. So after making zone splitter, we have to make a supply path. The supply path is just mentioning the splitters and mixer and the inlet node name. So here this would be AHU1, and please don't confuse with supply air path. This is actually the inlet for the inlet for the demand side. So this would be air demand inlet node 1, and this would be zone splitter, and here we will write AHU1 splitter. Okay, so this was for AHU1. For AHU2, uh, it's just for it's it's just for G1, as you can see here, VAV G1 and G2. So this would remain. This would be node 2, and these would be for G1 and G2. Box inlet, and this would make G2. For AHU3, it was DEF and H. So we'll mark inlet node as node 3, and this would be DEF. So uh, D inlet, then E inlet, then there would be F inlet, and then H1 and H2 inlet. As now we have made the splitters, the other things would be easy. We just have to mark other remaining AHUs. This would AHU2, and this would be node 2. Similarly, this would be AHU3 and node 3, and this would become 3. Okay, now this was a splitter which is actually responsible for splitting the air coming from AHU to the demand side. Now we'll make zone mixer, which will actually collect air from the different nodes, from the different VAVs. Sorry, here air won't be collecting from the VAVs, it would be from the zone, return node from the zone. You remember we had made here we had made this zone A return air node in this zone equipment connection. So we'll be using that actually here. The mixer would be very simple. We'll just write AHU and return air mixer. This node would be actually air demand outlet node 1. This is the node which is actually collecting all the return air and giving it to the AHUs. So AHU1 was connected to three zones: zone A return air, and zone B return air, and zone C return air. Similarly would be for AHU2. AHU2 is just connected to one, this that is G. So it would be just G return air node, and others would be empty. AHU3 would be connected to four zones that are D, E, F, D, F, then H. We'll also make the return air path. This is exactly what we did before. This would be AHU1 return air path. This would be air demand outlet node 1, and then we'll zone mixer, and here would be zone 1. Similarly, we'll do for the remaining zones, remaining AHUs. Okay, so now we have connected the demand side and supply side. The only thing remaining in air loop is actually set point managers. We have to make two set point managers. One would be set point outdoor air reset, and other would be set point manager mixed air coils. This mixed air set point manager is just used to control the loss which we get after using a fan, the heat release from fan. So we have to make a set point manager mixed air for every node um, before the fan. So we had made for mixed air node before by making OA mixed air temperature manager 1. Now we'll be making two sorry six for six remaining nodes. So for first we'll make a cooling coil manager 1. Except the set point node, everything else would be same here, because it's actually doing just one work. It's controlling the loss caused by a fan. So this would be outlet node 1, and this would be the same HC outlet node. This would be actually the cooling outlet node 1, the outlet for the cooling coil. Similarly, we'll do this for okay, so we have made all the set point manager for mixed air. Now the thing remaining is set point manager outdoor air reset. This particular set point manager actually resets the supply air temperature according to the outdoor air temperature. There are some specific rules for this. You can see the exact details in the IO reference. I'll just make it here now. We'll set the set point at outdoor low as 16.5, and outdoor low would be 15.5. Set point outdoor high would be 13.8, and this would be 21. Uh, the set point is actually the outlet of the this whole main air loop. So this would be air outlet node 1, and we'll repeat this for two more AHUs. So here we are almost done with the objects required to make a air loop HVAC. Next, we'll be covering, we haven't done a very big part. We haven't connected the heating coil with boilers. So in next video 1.6, we'll be doing that. That similar kind of work we have done before, so that video would be really small. The last part of that video would contain the remaining objects like zone infiltration, design specifications, and design specification for outdoor air. Then sizing parameters are left for zone, system, and plant. Then the thermostat configurations are left. So that will also be the end of this series.